In this video, I'm going to go over some sample problems from this worksheet, the worksheet that you have to do for light and energy, and it's also related to the lab. So we're going to look at questions 1, 11, and 18. So I've taken them and I've already put them into my notebook so I can do the math. Now, these problems should be straightforward. The hang-up that a lot of people have is not with the chemistry. The hang-up is with the with doing the math. So it's important that you do the math as kind of as best you can here. Let me get everything adjusted. Okay, so here we go. Okay, make sure you understand how to plug it into a calculator. I guess that's what I'm going to say. So it says, what is the wavelength of a wave having a frequency of this? Okay, so in order to solve this problem, we have to write what we're given. We're given the frequency equals 3.76 times 10 to the 14th 1 over seconds. This unit, seconds to the minus 1, is the same as 1 over seconds, which is the same as hertz. So don't get confused on that sort of stuff. And then the next thing is this. We were asked to find the wavelength. The wavelength equals, oh, sorry about that. That's what happens when your finger acts as a pen. So, okay. So wavelength equals question mark. Now, on that worksheet, you're actually given the formulas and the constants. So that's always good. Okay. And so what we know is that let me make sure that I say this since this is the first problem on here, is that we have frequency and we want to find wavelength. So you want to make sure you know which formula relates frequency to wavelength. Okay, and there are 2 or 3 formula that we have, but in this case, the formula is C equals, let me make sure I do that, C equals nu lambda. Okay, that's what I call Mary's formula. Now, what do we do from here? Well, now we plug in. Okay, so I'm going to plug in with a different color here. So C is 3 times 10, 3 times 10 to the 8th equals nu 3.76 times 10 to the 14th times lambda. And now we want to calculate what lambda is. So to do that, we divide. So 3.76 times 10 to the 14. Divide this side, 3.76 times 10 to the 14. And so what we get is, and I'll write that over here, and I'm gonna show you how to plug it into your calculator. And when we plug this in, we get 3 E8 divided by, let's make sure that we can read it. Yep. Okay. Divided by 3.76 E14. Okay. Now, that's how you would plug it into calculator. Remember, the E means times 10 to the. So when we do the math, the calculator sees it correctly, and we get an answer of, and again, I'll write that in a different thing, that lambda equals 7.98 times 10, look out here, right, times 10 to the negative 7th. Okay, and you can look up on this is in meters, and you can look up on the electromagnetic spectrum to see what that actually is. Okay, what kind of wavelength, because that's the other part of the question, what kind of wavelength of light that is. Okay, so let's look at question number 11. Okay, so it says, what is the energy? Okay, so I'm going to do the same thing. I'm going to always solve these problems the same way. We write what we're given. What is the energy of a wave that has a frequency, okay, of that? How do I know it's a frequency? Because the unit, hertz, is a frequency. So nu equals, frequency equals 7.66 times 10 to the 14th hertz. Okay. And we're trying to find E. E equals question mark. So I'm sorry that this for some reason is doing crazy things. Okay. So what formula relates energy to frequency? Okay. Well, it happens to be E equals H nu. It's the one that has both energy and frequency in it. Okay, well, we're trying to solve for energy, so let's plug it in. Okay, so E equals H is Planck's constant, and you'll see Planck's constant written out a bunch of different ways. Okay, it's either going to be 6.6 or 6.63 or 6.626. It's all kind of the same thing, and it's a constant, so you don't have to worry about sig figs. Constants have unlimited numbers of sig figs. So it's 6.6. I'll use whatever's on this worksheet. 6.626 times 2 times 10 to the negative 34. Okay, so that gets us there. So 6.6262 times 10 to the negative 34. Okay, and now I'm gonna put that in parentheses here. I probably won't do it in my calculator. Times 7.66 times 10 to the 14th. Now this is slightly easier to answer because now all we have to do is do 6.6262 in E. Remember, E means times 10 to the negative 34. So that's 6.6262 times 10 to the negative 34 times 7.66 E14. And when we do that, we get an energy. The energy equals 5.08 times 10 to the negative 19. And the units of energy are joules. Okay? And then again, you can look up where that frequency falls on an electromagnetic spectrum. And then the last one is to determine the energy given a wavelength. Okay, well, what are we given in the problem? Let's write what we're given in the problem. We're given a wavelength, lambda equals 9330 centimeters, and we're trying to find energy. Energy equals question mark. Okay. Now, this problem is slightly different because we have to make sure that our units are in meters before we do anything else. So we have to convert this to meters. Okay, so I'm going to do that. Convert, then calculate. So I'll do that in a different color here. I'll do conversions in green. And so it's 9330 centimeters, X line, centimeters on the bottom, meters on the top, and it's 10 to the second centimeters equals 1 meter. And now we go 9330 divided by, and 10 to the second is a 100, so I'm just going to do that because that one's a little easier. So this is 93.3. Now your calculator writes it like that, so we're going to do that. So that's that many centimeters. Now we're ready to figure out what the formula is, and the formula that relates energy to wavelength is E equals hc over lambda. Okay, and now we plug it in. Okay. E, we don't know the energy, So that becomes E equals H 6.66262 times 10 to the negative 34 times C is 3 times 10 to the 8th over lambda wavelength 90. Oh, I'm sorry. Look, this is me. That's 93.3 meters. Wow. See, this is me not doing my X line right. Okay, so it's 93.3 meters. Okay, good. So now how does that look in a calculator? 6.6262 E negative 34 times 3 E 8. Remember that E means times 10 to the. Okay. And now I'm gonna hit enter here just because that's my numerator, and now I'm gonna divide that whole thing by 93.3. By doing that, I get the energy. Equals 2.13 times 10 to the negative 27. And that's in joules, and that's how much energy one photon has in this wavelength. Okay, so hopefully you can work through the rest of the problems. You can always come back to this video, see the samples, work through it. Remember always to convert before you calculate, and have at it.